Recording in progress.
All right, good morning. Today is our first true lesson on Google Earth Engine. You have successfully learned how to run GitHub, or at least you have a video and a tutorial to refer to for that. Second, we make sure that GitHub, Google Earth Engine, and HydroShare JupyterLab talk to each other. Okay, now we're ready to run code. So today we are going to check. We have a folder where we cloned stuff, right? We have a folder where we have EEMONT, GEEMAP, and then remote sensing of land surface laboratory, right? Okay, and then we have a folder, what we call it USU assignments, remote sensing assignment, where you're going to put your assignment, and you're going to, once you're done with your assignment, you will send it to the cloud. You will send it to your GitHub repository. So we'll try to do all of that today. Okay, first let's go to remote sensing of land surfaces, to that folder. And you will have different notebooks there. Now, here I need to ask, who knows Python? A bit. Yes, yes, yes. How is your programming skills in any language? Huh?
I think I can catch them.
Okay, very good. All right, let's open from the laboratory lab number 1, Intro to Remote Sensing and EEE. Okay, so this is a sort of a template, but the idea is that you won't use this notebook to do your homework. You will create your own. So I'll show you how to create your own. Okay, this as Jupyter Notebook is a series of cells where you can introduce code, Python code, you can introduce text, or you can introduce raw text. Raw text means that is a text that is not formatted, like this text here is text that is formatted in what is called markdown language. Markdown language, it's, for example, if I remove this hash from the first line, I delete it, and I run the cell, the title of the lab just becomes a general text. I click again on the cell, I put the hash back, run the cell, now it's a title. So Markdown has a series of commands of format that allows you to create text that can be recognized as titles, section, subsection, or links to websites. So this is a link to a website that will take me to Google Earth Engine. So how that link was built, you click on the text, and I have to create the text that is going to be the link, and next to it I have to put the web address. With those, it's like Markdown has that sort of command to create text. So how the notebook knows that it's a Markdown cell? Here you choose the option. You will choose code, if it's Python code, Markdown, or raw text. So if I put this cell like raw, and I run that cell, just generic text. If I click again, change it to code, and try to run it, it's going to say, hey, this is not syntax for Python. Click again, change it to Markdown, and run. I get my text back. So we control what is the format of every cell. So you can put your name, the date when you're preparing the assignment. You can give it format, or you can use raw text to explain the steps that you are doing. The idea of the notebook is that you pass code, but also you explain what are you running in that cell. So it's like creating a tutorial, but in coding. So that's the idea of this. And the good thing is that this is printable. This allows us to print it in a PDF. And when we print it in PDF, we will have the code, but also we will have the images, the results of the Python code being run. So it becomes like a nice printout tutorial for somebody else or for yourself. Or for me, I can see your code and your results at the same time in that printout. Okay, is that is a quick explanation of Jupyter notebooks. So they're becoming very common now in academia. Many professors are changing from teaching raw Python to Jupyter notebook because of this flexibility to annotate or put documentation or explaining what's happening along with the code. So we will use that for teaching the lectures, but also for your assignments. Okay. Okay. So one thing that we need to have into consideration when we're using GEEMAP, the Python library that we are going to use for coding Python with Google Earth Engine, is that before running, we need to open a terminal. How do we open a terminal? We go to File, New, Terminal. So here we will pass a command every time. Why? What happened? So when you open your account in HydroShare JupyterLab, it start allocating computation resources somewhere in the cloud. When you log out or when you leave it, if it detects certain hours of inactivity, it will shut down. Okay, so it will shut down. So whatever command you pass to the Python environment is forgotten. So what is forgotten from last Friday to today is the update that we request for Google for GEEMAP. The update is pip install -U space GEEMAP. We will pass this command always we want to work with Google Earth Engine here. So this is the command that every time you left this JupyterLab out, or you leave the environment or nowhere, it will forget it later. All your data, your code will still be there. I've been using it and I've been storing code for years here. Nothing had been lost, but it will forget what you sent or what changes you do to the Python environment. And this is one. So we will pass this command, press enter, and you should see a lot of commands being run. Done. Now we're ready. Okay, is everybody there? Yeah, very good. So now we can run the cells. As I say, as I mentioned before, one of the potential issues with a notebook is that you can run each cell at any time. I could run the last cell of this code with regardless of the previous ones. And if you are doing a sequential analysis, that might introduce error later. So it's important to run from top to bottom. So you get the linkage of the results of the different cells affecting your later cells or being used by your later cells. Okay, so let's start running cells. Lab 1, this is a tiny command that it will give me an output. In this case, I'm asking to print out who updated this file and give me the date of today. in this specific format. Month, day, and year. So the first thing that you want to do in remote sensing is to get data, right? You want to see the latest Landsat or the latest satellite image for Logan, for Michigan, for any location, right? So this first lab, and we will try to do lab 1 and lab 2 today, is that task. How do I get the latest image from my favorite satellite for the location that I want? Okay, so that's the lab for today. So we will run this cell. We always start with these 4 commands in all notebooks. Okay, so this will be like a default cell when you do your assignment. Run it. What it's doing is calling the module EE and it's asking it to initialize, and then it's calling the module GEEMAP, and also it's calling color maps. GEEMAP, the latest version of GEEMAP, has color bars that can help us to change from a grayscale color to a different color pattern. So the example uses San Francisco, but we can change this to another location. Give me a location in the world. Iran. Oh, Iran. Sure. Okay, where is Iran?
I think you have, sorry, the version. 37 feet wide.
Well, okay, so I'm leaving you here a really nice link. If you click on that link, this is a latitude and longitude finder. So how we will find imagery, we need to find the coordinates of that. So let's say, where is Lake Urmia? Lake Urmia, let's see if it finds it. Let's see. Is that Lake Urmia? That's not Lake Urmia. Do you know which district region name where Lake Urmia is?
Tabriz, Lumia, and the name of cities.
Will you type the name? I couldn't catch it. Let's see if it can find it. And you can type any location you want. Okay. Tabriz, Tabriz. Yeah, so.
Okay, it should be some place close to here.
Okay, Lake Urmia is there. There is a place called Urmia.
Yeah, the name of city also is Lumia.
Okay, well, let's try Urmia. Urmia. Oh, this is another location. Oh, it's next to the lake. Okay, this looks better. Okay, so what I'm doing is I'm looking for my favorite place in the world and I'm getting the latitude and longitude. Okay, so I'm going to copy this value. I'm going to my notebook and I'm going to paste it where latitude is. Go back to the code. Paste it where longitude is. Okay, yeah.
Or this like this assignment, do you want us to make a copy of this and have it on our?
For now, no. For now, I'm teaching you how to deal with the notebooks. But later, after we finish this section, I'll show you how to create a notebook, start the field cells, and then send it to the cloud. But yeah, good question. Yeah.
I have something about the engine, like how they're running some patient.
Let me see.
It's right, but give me not error, but an exception. See, let's see. This is the okay. The GEEMAP 2 there. Oh, it has forgotten your. Have you finished authenticating the GEEMAP? Getting the password? Yeah, that's the thing. Okay.
All right, go
But it's
to,
better.
go to remote sensing. You remember what you do the GEEMAP folder? We clone it.
I don't remember when
Okay, because we need, because remember we ran that example one of the notebooks last time, and it asked to, hey, you need to authenticate your account. You have to link your Google account with Google Engine, give you a password, and you have to copy and paste that password. Yeah. Okay. So, okay, so you put your favorite place in the world there. Okay, so how Google Earth Engine is going to, well, let's run this cell. So now we have a couple of variables. Now we're going to send this information to Google Earth Engine as a point. So the EE in the cell number, in the cell where the mouse is going to create a geometry and a point based on the latitude and longitude, and is going to store it in a variable point. All right. Now, in this case, we're going to call Landsat. But in lab number 2, we also can call Sentinel or other data. So to give you an idea what we have in a store, this is Google Earth Engine, and this is the catalog. This is the home page. Okay, if we navigate down, we have data regarding surface temperature, climate, atmospheric data, weather data, and imagery. We will have Landsat, Sentinel, MODIS, and high-resolution data from the US National Agriculture Imagery Program. This is 1 meter resolution data, but this data is collected every 5 years. So we have these 4 options in the catalog, but nothing impedes us to upload, let's say, a drone image to Google Earth Engine and use, at that moment, we can call that image from our code and do the data transformation as we need it. So for now, in our code, yes.
the difference between the Landsat, Sentinel, and MODIS.
Oh, is the resolution mostly. 2 resolutions, the frequency resolution and the pixel size or the spatial resolution. Landsat is the longest program, the longest monitoring program on Earth. It spanned 40 years of an archive of data. The early first 20 is wishy-washy because the program didn't have enough funding, rely on other organizations to store the data. The other organization didn't store the data. So we have few images from the first 20 years, but for the last 20, we got every picture in the planet. The resolution of Landsat is 30 meters. The data is available every 16 days. Sentinel is an effort from the European Space Agency. There are 2 satellites called Sentinel-2 A and B, Sentinel-2A, Sentinel-2B. There are other Sentinels, but they don't provide imagery data. They provide radar data or temperature data. So the Sentinel that provides this type of visual is Sentinel-2. The resolution is 10 meters. So it's better than Landsat at 30 meters. And the frequency of the data is every 5 days. So it beats Landsat because Landsat is 16 days and there is just 1 satellite. Now, the thing is that Landsat, besides the optical data and the near infrared data we were discussing yesterday, it also has thermal. Sentinel-2 doesn't have thermal. It's just pure visual and infrared data. They make a mistake. Okay. Nevertheless, they're going to launch now they're preparing to launch a complementary satellite to capture the optical and near infrared plus the thermal, hopefully at 30 meters or 10 meters. We don't know yet the specs of the thermal data, but at that moment, Sentinel and Landsat will be like twins. The difference will be in their pixel resolution, but if Landsat is coming at 16 days and Sentinel is coming every 5 days, so you have more data, if more time series data for a location if you combine the two sources, and that's the idea. Okay. MODIS is a satellite that was designed to study the Earth weather patterns, but also the surface. The pixel resolution is from 0.5 kilometer for some cameras to 1 kilometer for the thermal cameras. So the image, you can see, or the example is that you can see almost, you can see larger areas of the globe with MODIS. Landsat will see use smaller areas, and Sentinel also will see smaller areas. The area that a Landsat image can cover is 180 but 180 kilometers. That's the area. So to cover Utah, the entire state of Utah with Landsat images, we need like, it's about 14 Landsat images to cover the entire state with Landsat images. But with MODIS, it's just one image. And that image is covering almost 75% of the continental US. That's MODIS. So wider pixels. So the field of view is wider, but it has like other types of application like weather or trends in climate or broad view of hydrological basins. But if we want to study specific fields or the behavior of lakes, Landsat and Sentinel. So finer details, Landsat and Sentinel, a broader or wider scale, MODIS. And the high resolution imagery is 1 meter. In some locations, few locations, is 1 foot per pixel. So it's very high resolution. You can tell cars from the image. But this is like Cache Valley gets an update of the NAIP, this high resolution image, every 5 years. So this is more like a long-term monitoring to see if urban areas are growing, fences or delimitation of agricultural properties, if a field that was irrigated by flooding irrigation now uses center pivots. So it allows us to track changes, that fine detail changes with high resolution. Should be more frequent? Yes. There is now companies that are providing data for a cost. There is a company called Planet, and they provide daily data at 3 meter resolution. And this is their program is designed to support, let's say, large businesses like large agricultural companies in California. They can use, as we are developing code, they also develop code to extract the data from the Planet archive, process it, and have immediate answers for their monitoring of their fields. For example, like these days is raining a lot. They want to know what the situation of the different vineyard fields that they have all across California. They can hire or buy data from Planet, and they can run the code and check for every field. What's the status? Is it flooded, or the flood did minor damage or severe damage? So that's another option. So how do, in our first notebook, the next line that says Landsat is going to call an address. is saying here, image collection, and that's how we're going to refer to an archive of data. An archive of data is going to be called image collection. A single image, one image will be image, but the entire archive is the image collection. And then we will have a sort of address, okay? And that address comes from that website that I'm just showing you. Let's go to, let me close this one so you get confused. Okay, here we're in Landsat. We go to explore Landsat. So we have what is called the collection 2. Landsat is upgrading their algorithm. So collection 2 has the highest quality products of the Landsat satellite. So we have Landsat 9, Landsat 8, Landsat 7, and it's showing you from which year to which till when that satellite was in space collecting data. So we have Landsat 5, Landsat 4, and the first Landsats ever launched to space. So let's use Landsat 8 or Landsat 9. Here in Landsat 9, remember that yesterday we talked about top of the atmosphere surface reflectance? Who remembers that? What does it mean, top of the atmosphere? We talked about that yesterday, so.
That hasn't been corrected.
Yeah, remember that scattering of light and the image being bluish? This one is that data. So if you can, avoid it, okay? Don't use it. This is even more unprocessed data. This is as it coming from directly from the satellite without any sort of correction, no reflectance calculation. This raw, completely avoidance, okay? What you are looking for is these keywords, surface reflectance. This is the best data. You might find that on some occasion, you use this, but you need to make sure that you apply or learn a technique to convert this data to surface reflectance. But that's very rare because now, when I was studying remote sensing, NASA only provided this. So we had to learn how to do the correction. But now NASA produced this. So this is now for the old folks or people that dedicate their life to process or on basic process of satellite images. Okay, so here in surface reflectance, let's click on surface reflectance. Okay, now, where is the address? Here. To call this archive of data, you have to have EE, image collection, the archive, and this address. That's what it's saying. For every satellite, for every product, is going to be an address like this. So you just copy. Go to your notebook and you change it. Yes?
How did you show like mass quality? So if you look at everything in the website, you could have like an idea of what the collection looks inside. You gotta go back to the Earth engine website where you got the link from.
Yes.
But how do you know what's exactly in this archive?
Oh, okay. So here, a good question. The description, these tabs at the bottom are important. It is an explanation of the data that it has. What bands? And here it comes. Remember I told you to memorize something? Did you memorize it already? Because here is the quiz. Okay. Landsat here Google Earth Engine, make us a favor, put in like the colors here in the description. But if you download imagery from NASA, they just give you these values. They tell you this name and this column. That's it. So what is SR underscore B3? The wavelet is 0.533 to 0.590 microns. That's green, okay? But just for the number, if it's in the 500, it's green, okay? So here we have it easy for us, but yeah, knowing that scale, that little table, will help you to recognize if a band is green, is infrared, mid-infrared. So here at the bottom are other additional bands. Band 10, STB10 is surface temperature. So once we get more into detail, we will call a specific bands. Right now, we're calling the entire archive. Hey, Google Earth Engine, give me the entire archive you have. Okay, let's run that cell. Okay, here, this figure below might be unupdated because I was using Landsat 8. But there is one thing that you need to learn from this website. Let me see, where is it? Aerosol attributes, pixel distance to cloud. QAQ pixel processing level. Oh, they did change it again. In some of the products, there is one additional band where they mention if a pixel is a cloud pixel or not. So in this case, they remove, in this specific product, they remove it, but they left me this. So we will, for now, we will ignore that cell because it's not going to do me much more. Okay. So our image collection, the entire image collection is in this variable. Does it mean Google Earth Engine has put it into memory, the entire collection? No, it just put a pointer to that data. Okay. Now, in this cell, we're going to tell them, remember, we're thinking about Iran, like Ormia, or you're choosing another place. Okay. Now we need to tell them for which period or which date we want Landsat. So what if I want today? I need to make sure that the satellite is collecting till now. So let's see, it's collected from 2021 till 2023, the last 2 days ago. That's the data that it has. So, okay. So Lake Urmia, how's the weather in Lake Urmia right now? Is it snowy? There is no snow there.
Yeah, yeah.
Is it in Lake Urmia?
Yeah, we've got most of the snow there.
Okay, so we want summer. We want something that let us see the, so July is summer?
Yeah.
Okay, so, okay, now what I'm going to ask is from that archive, I want the image of Landsat of July of last year. Okay, so I'm going to say image, EE image, this is the entire archive, dot 2022, July 1st, sorry, need to put 2022, July 31st. So I'm reducing my range of search on the archive to 1 month. Now, but the entire archive is for the entire planet. I need to locate it to a specific location. So I'm going to say filter bound point to the variable point. What was my variable point in my code? The latitude and longitude that I enter. And for now, let's left the sort cloud cover land. That's a command when you have that variable part of the archive. In this case, is not, so it won't affect the run. But the last command is the important. So if I'm asking for a month and Landsat is happening every 16 days, there is a chance that I have 2 images in July. So when I say at the end, give me the first image, it's going to give me one of those potentially 2 images that can happen in July. Okay. So then I pass a command, and this is, oh, give me the date of the image. So let's run that cell, this cell. Okay, it's saying the Julian date of the image, the first image for the Lake Urmia is the Julian date is 199. Now in the variable image, we just have 1 image from the entire archive. Now, what I want to know is what bands it has. Does it has the blue, the green, the near infrared, the red? So I'm going to pass this command, image, band names, and then print out those names. Here is where we learn about the bands. It's showing me these values. SRB1, SRB2, SRB3. So what does it mean? I go back to my Google Engine Data Catalog, and the names of the bands are in the description. SBR1 is ultra blue. SBR2 is blue. SBR3 green. SBR4 red. To create a true color image or a human color image, I need red, green, and blue. I need it in that order. So which bands I need to create a true color image? To create a human picture, I need 3 colors, right? Red, green, and blue, in that order. Which bands what's the name of the bands that I need to retrieve to create that image based on that band naming there?
B4, B3, B2.
Yes, and I need it in that sequence. Okay, very good. So now that we have that information, I see B4, B3, B2. Okay, that's good. Let's keep running. This is for Landsat 8, so let's not consider that here. Now, another component on image transformation is that sometimes to save space, they will multiply the image by a factor. So remember the reflectance is from 0 to 1. So there could be 0.32, 0.35555. So to avoid decimals, the NASA people will multiply the image by 10,000, saving 4 decimals. And so to use the image, you have to divide or to multiply a factor, the factor that they use it to convert it to a scale from 0 to 1. So let's check if there is a factor here. Okay, here it says that there is a scale. Look, there is a scale and an offset. What does it mean, a scale and an offset? And the values are the same for SBR, B1, B2 until B5. in this case, they not only multiply by a value, they also subtracted a value. So to convert it back, we'll have to do something like this. Image, select from those images SRB1, because that's the names, SRB2, SRB3, SRB4. But you might say, but why I have to do all this work? Well, once you have your code ready, you can run it anytime. Okay. And then it says I need to, so once I selected the bands SR_B1 till B7, then according to the description, I have to multiply by this factor. And then dot, I need to, let me see what else it says. It says an offset. I need to say at Does it make sense? Okay, let's run it. Okay. Wait, but
You have to include all the bands, or you can just include 2, 3, 4, the one only.
we could select only few of them, but I want to show you how to combine bands. So I'm selecting all the optical and infrared band from B1 to B7, but you're right. I could have selected only B4, B3, and B2. Okay. Then here is the command in GEEMAP that will create a map. I can say map set center. In this case, the coordinates that I have here are the coordinates that I use for my point. So I can update this by bringing those coordinates. Oh, I could say longitude and latitude. That will be. Okay, I could say latitude, longitude. The zoom will approach the camera or the view closer to Earth or farther away. Let's give it a try to this cell. Let's run it. It's quite far away. Now I can change the zoom. Let's change zoom 1. Let's rerun this cell again. If I put zoom 1, let me see the entire planet. Zoom 4. Let's try, I think the maximum is zoom 12. This is zoom 12. So, but I want to see the lake, so let me put zoom 10.
Shows me. I tried 5, it shows me whole of the.
Say that again.
I tried 5, it shows me whole of the page, maybe 5 or 6.
Yeah, if you try 5, you get the lake there. Okay, so the zoom is something that you will play with. Okay, it's under your control. Okay, so okay, we already have what, more than half an hour and I don't see the image. Okay, where is the image? Here. Okay, let me see, we run this cell. Yes, don't run the next cell. Why I have, it's a duplicated cell. Don't run this, oh, map set center. Let's comment this one. No, well, commenting is with the hashtag. Okay. And then the following command says map. The variable map is the map. Add layer. So that's how we add images to the map. Add image. What are the bands I'm going to display? 4, 3, 2, red, green, blue. Call it Landsat. Let's run this cell.
You have to update the names.
Oh, yes, you are right. SR. Okay, let's run it. That's the image.
Did you control like how much to cut for the whole image?
The zoom.
Not the zoom. So did you define that area or that just one pixel?
No, this is the image, but I'm too far away.
Right?
Yes. It's just that
This image, did you define the boundaries for this area of black one?
no, this is the image. This is the 180 by 180 kilometers.
Oh, and that just took the center you provided, and then we just took it.
Yes.
180 kilometers.
Yes. So it's huge, the image. So you can zoom in, zoom out with the controls, but it doesn't look okay, right? It looks too dark. It doesn't look like the pictures that are showing maps. And this is the reason. There is one command that you need to know, or one concept you need to know. Reflectance data. Reflectance data is scaled from 0 to 1. What is the surface material that can reach 1? Snow. Okay, it's 0.9, 0.95. But there is no snow in this image. So it's like when you take a picture, okay, and you change the exposure of the camera. If you increase the exposure, the image is brighter. If you reduce the exposure, the image is dark. So in this case, Google Earth Engine is forcing the values to be from 0 to 1, but nothing in this image is snow. So everything looks dark. Everything is in 0.3, 0.4, 0.5. So what if I tell Google Earth Engine, hey, don't use your scale from 0 to 1, do it from 0 to 0.5. So, and that's the next step. Here, we're going to update these values. SRB4, SRB3, SRB2. I'm going to tell him directly the minimum value 0, the maximum value 0.5. Okay, run that cell and then run the next cell. It's the same image, just instead of displaying from 0 to 1, now it's displaying from 0 to 0.5. It's still dark in this area, but this is very bright. The shorelines of Lake Urmia is very bright. Can I know the value of these pixels? Yes. So here you have an icon, a range. I see you click here in Inspector. Then you click the location you are interested on. here is the Landsat. This is the original, the dark one that is behind this one, and this is the stretched. The values, by forcing Landsat to say from 0 to 0.5, we're just changing the display, but we're not changing the values. The values are still the same. So band 1 is the same, band 2. Look, band 4 is 0.57. This is infrared. No, sorry, red. The red band. So we chose a very good value, a very good high value to stretch our map. But just for fun, okay, let's change it to 0.3, the previous cell. Let's run it. And let's run the next cell again. Looks brighter. Okay. So now this area looks overexposed, very bright, like you get in pictures, and that's the reason. But again, the values here never change it. It's just a trick for our eyes to see better. Fun? Fun. Which locations you were looking at? I was working on Urmia. You?
I'm the same.
You? Urmia? You?
Denver.
Denver?
I just stuck with San Francisco.
Okay, you?
The coast of North Carolina.
Oh,
It's not working.
oh yeah, yes.
Urmia.
Urmia. Okay, fun. Okay, let me see what you got.
I got some areas that I could use some help with.
Okay, let's pause here. Okay,
It's starting with this one. It gave me.
let me see.
Yeah, I need to zoom it in a little more. But
So I need to see
Oh, there.
the bottom. The last line is there. It says
So
bad time. It's go back. Oh, June only has 30 days.
I was doing June to July, that's why. Okay.
Give it the run.
Yeah,
There you
that
go.
should serve
Okay.
Okay.
Okay. You.
it. I should send it in.
Yeah, with you. Yes. And you, North Carolina. Yeah, still, yeah, when you get clouds, clouds also have a reflectance close to 1. So you have to put that value that we changed, put it to 0.3, especially with water. Water reflectance is extremely low. So you have to put 0.3 to visualize it better.
What is the zoom scale? Like 0 to.
0 to 12, 0 to no, 1 to 16, I think.
Good question. To say that Denver is like,
Yeah.
right behind that, but it's like right at the edge of the.
Oh, yeah.
Maybe
So,
2 or
yeah.
something like that.
Choose a location order in your coordinates. Well, like when you choose the place in that website, choose a location app, and then with that you bring the right image to it.
Can you define 2 points in the sample map?
If you that happens, what happened? I mean, we chose in this case the Urmia town that is used here. Okay, the Landsat images has a trick. If you are at the very edge here, okay, it can call images from above and from below. Okay, but when you say in your command, bring me the first image, it's going to choose the one that was the most recent. So it's going to pick up 1. So that's the thing. The other thing to do, it will be to put another coordinate, call another image, and map it in the same fashion as you did this one too. So it's possible to have multiple images in the display.
I was gonna say, if you have like a list of points, you could kind of make a loop.
Is yeah, you make a loop and you get all of them displayed. Fun?
I did some weird stuff out in the ocean. I don't know.
Let's
It's
see.
like parts of like really blue
Oh, that, yeah, when you see that is that the algorithm that does the surface correction, they, in water, especially with water that is moving, creates some glare. And it might be confusing it for clouds or something that will affect water.
Okay.
So if you are studying water, the surface reflectance or the top of the atmosphere data might be better, but it would require some less aggressive algorithm for removal of the scattering of light. But yeah, that tends to happen.
Yes.
Okay, now yours is working nice. You got a huge cloud there for you.
Yeah.
Yes.
So just like a generic question, we want to have the same so they can see how the band will change in like 50 years, 20 years, 10 years. So do we just use the RGB bands or different?
Well, let's see. That's the next step here. Okay, which bands will help me more? RGB, near infrared. So that's a question that every student and professional of remote sensing ask. We call for this image 7 bands from SR_B1 till 7, but we're using only 3 here, right? 4, 4, 3, 1. What if we change it? Let's do that. Okay, now let's keep running on the code. Okay, now we're going to call what is called, what you saw in your computers is called true image or human color image. Now let's change the red for infrared. Oh, let's see. Okay, so the bands are going to be SR_B5, SR_B4, SR_B3. Let's leave from 0 to 0.5. Let's run that cell. Let's run the next cell. We can close this view. Okay. So what happened now?
Really small.
I can see very clearly water. So the use, remember, what was the property of near infrared and water when we were discussing the spectral curve of water yesterday? 0, right? Let's check. Zoom in, click on the eye, click on the water. B5, what's the value? 0.02 versus red 0.17 versus green 0.22. This is extremely small. It's basically part of the noise. So what I'm seeing, these colors are actually water, are actually the extent of the liquid water in the lake. So if I were to study any water body, Grayson Lake or Lake Urmia, I will use this combination of colors: near infrared, green, blue. Because this shoreline that you are seeing here is the true shoreline of the water. It's very clear. And if you want to do a series of images, as we call it for July 22, you can call July 21, July 20. So you can create your time series or your visual views of the Salt Lake, the Great Salt Lake over time. Fun? Okay. Questions so far? This is the basic, the most fundamental way to interact with data. So this has to be very clear for you. So you have questions, ask now.
Yeah, it's later.
Maybe. Question? Okay. All right. So let's see. Now, what is left here is that what if I want to extract the values that I'm in the, like how I can extract these values in a table, okay? Because remember the spectral curve? Let's try to reproduce the spectral curve with Landsat data for a location here, okay? So what I'm going to need to do that for a specific point, I need the coordinates of that point. Where are the coordinates of where I click? Here. When I do the search of these values, I get the coordinates of the point. So I can use them now to try to reconstruct the spectral curve. So here at the bottom is, I need a point. So I'm going to copy the values here from the image. Where is my image? Okay. It's 41,313. 41.353. And I'm going to use 38.095. Okay. And then I need to tell what are the names of the bands. SR underscore, SR underscore, SR underscore, SR underscore, SR underscore, SR underscore, SR underscore. Now, the other information that I need is what is the wavelet of every band. The wavelet of every band, or the mean value, is here. We don't have it. We just have this range. So we have here, it should be 44, here 47, here 56. Let's see if what I have in my code. 44, 48, 46. So these are the right values, the intermediate values of every band. So every band, as you were asking last time, it measures a tiny range of wavelength. Okay, it cannot measure one wavelength. The camera, that type of camera doesn't exist. So it need to let pass a little more light. So this is the range of photons of light that this camera in the satellite can let pass. So what we need is the mean value of these values. So I have them typed there for you. So if we use another satellite like Sentinel-2, they will have a different range of values. But how we calculate it? By just taking the average value for every satellite. So let's run this. Now, the pixel size of Landsat is 30 meters. So I'm going to say, give me a sample that is 30 meters wide. And to my image, I'm going to pass a command that says reduce region. Reduce region is give me a statistic. The statistics being the type average on the location that I say in this variable GE_park. GE_park is my coordinate of that point where I want to, and the scale. Let's run that. Done. Now let's look at the values that that point has. Sorry, what's happening here? Band reflectance. Okay, here value info. Results get info. It didn't calculate it, and I don't know why. Unless my coordinates are. Did you get it? Did you get these values, reflectance values?
I did, yeah, my coordinates are different from yours, so.
Yeah, the only thing
Try
that.
like 45 instead of 40,
Say that again.
try 45,
45 on the first.
yeah, 45, 45, what I use. And 37.932.
37.92. Let's see. Yes, that's weird. Okay.
So when I clicked it, those are the values I got.
Yeah. So here are, maybe I misconfused a value mine and I was out of the image. So that's what I think was my error. So here are the reflectance values of that particular point. So now I can plot them. So if we run the next line, this is the spectral, an approximation to the spectral, the blue, green, red, near infrared, and so on.
Then you would go to a reference, spectral, and then you would know what kind of color is coming.
Say that again.
Now we have this one.
Yes.
We go to a reference, spectral signature. And this is how we know what kind of.
We have an idea.
uh,
We have an idea, but still we don't use directly this curve. Okay, this gives us an idea. Oh, this is water. This is in the near infrared, which is about 0.8 and forward. Look, the values are extremely low, and we have the peak of water. Soil will be a concave shape, and vegetation will be, it will have the red edge at 700 that go up. Good question. All right, fun? More or less? Okay. All right. Let's leave it there. Okay, let's say yes.
How you would export the image?
Oh, that's okay. Hold that thought. Okay, I'll show you how to export an image. That, or maybe we can do it now. Let me see. Let's go to your folders. Let's go to GEMAP. Okay, let's go to examples, notebooks. Okay, and let me see. And this is why I want you, when you have time, explore those notebooks from GEMAP, because there are some questions like, instead of getting the average of a point, could I get it for a region? So I can draw a region that, like, with coordinates, and get the average values or the maximum values, the minimum values. And those examples are here in the notes of GEMAP. But here, notebook number 11 in GEMAP is this one. Will export an image. So how do you export an image? Well, here, if you watch the YouTube video, is going to do something, it's going to split. There are two ways. You can draw in the map, or you can pass coordinates. I recommend passing coordinates because every time you draw something, you will get different corners or different area, slightly different. So how do I pass a coordinate? We're going to copy this. We did here. We need a geometry. Let's go at the bottom. You will always see a empty cell pasted there. I need to have a closing here. Okay. Yep. Then I need to convert that into a feature. I'm going to copy this to additionally. Okay, so what I'm going to pass is a geometry. Okay, a polygon. I'm going to convert it to a feature, and the ROI is going to allocate these coordinates for analysis. The other thing we need is what directory you're going to save the data. So that's the next cell. Just copy, paste it on a new cell. How you create a new cell? The plus icon here.
Where was that?
Say that again.
Where was the plus like? Oh,
Here.
that one.
Yeah. Let's go back. Here, this is the command. Export all images in one single image. Copy. Create a new cell. Paste it. Okay, now we need coordinates. Remember, we're in Lake Urmia, and this is GEEMAP example, so these coordinates are off. So let's figure out coordinates. So let's go to Lake Urmia. Okay, let me, what is this? Okay. Okay. I'm going to select, you select 4 points. 1, okay. And I'm waiting for my coordinate there. Do you allow me to copy? Yes, this is longitude, latitude. Okay, but do you allow me to copy? No, need to do it manually. Okay. 44988. What was the other one? 37804. Okay, and now I need another point here. Now I'll do this one. Now I'll do this one here. Okay, 45. The 37799. Okay. Okay, now another point. One of the things, try to do it with a small area initially. Don't try to export the entire image. There is a limit of what Google Earth Engine lets you export. Oh, the next point is this one. Okay, 45,309. .309. 37.5. Or okay, one more. One more. Okay. Let's try here. Okay. 45.7. 45. And I'm going to delete this one. Okay. Okay, I got my 4 points. Going to run it. Then here is where we are going to tell it where to store the data. Here we're saying download. Let's change that name to exported images. Okay, so we know that this is our folder. So this command, what it says is, we're going to find where you are in your computer, and we're going to add a folder, call it exported images. And the name of the file exported is going to be Landsat diff. I can change it, Landsat _ example diff. Always the image has to end in .tif. .tif. If you don't include this one, no computer will recognize what type of file is. Okay. Let's run that one. Oh, OS is not defined. OS is a library in Python. So I have to say import OS. Run again. No error. Now, the last one. Here is saying clip the image to this area called ROI, which is my geometry. Okay. The second is says export the image clip it with the name Landsat example, scale 90. Do I want 90 or 30 meters? This is 30 meters, so let's put it 30. Region, the ROI, and file per band. If you file per band is, do you want all the images separated? Camera 1, camera 2, camera 3, or all of them together? So the default is together, so false. But if you only want, you're going to then select I only need the band 4 and the band 3. I don't care the rest. You might select here band file per band true. Let's run it. Okay, this is the error that I get. The size of the area is too big for the allocated area. Damn it. So I need to rework my coordinates. Okay, I am at 44, 45. Okay, how do I reduce my coordinates? 37. This is longitude. This is latitude. Maybe if I am at the same latitude. Okay. So this is the same longitude. Then the latitude is going to be different. Okay. Okay, still too big. Okay. Okay, it's closer. Okay. This one should be the same as this one. Okay. You know what I'm doing? I'm drawing a square with my coordinates. 5.3. Oh, I increase it. Oh, yeah. Increase it. Copy, paste. Okay. That should make it. Almost there. Okay. This is the upper one. So if I change it to 6. Okay. There we go. It's downloading the data. Oh, there's an error there. What happened? Again, and again. Did you get the error?
Yeah.
Okay. Are you try reducing the coordinates, still getting too big to download, or you got the?
It doesn't say it's too big. It's just an error.
Just an error. Okay. When that happened, and it, okay, when you know a cell is running with there is a star next to it. Okay. So to make sure that there is no errors, you need to stop the kernel or the Python environment. So you go to kernel here, and you say interrupt kernel. Okay. So what we can do now, what we can do is, let's see, does it allow me to run this cell? Yes. This one too. This one. An error occurred during downloading.
I think that's my token is going here.
Your token? Your Google engine? Huh. That's weird. Okay. To reduce this, let's change the scale from 30 to 60 to see if that was. But first we need to just interrupt the kernel and run this guy. Weird. Let's restart kernel. Restart. Okay. I need to let me do a run all cells. But if thinking, let's see.
So to run everything over again from the start, you just say restart kernel and then run all cells.
Yes, you restart kernel, and then I say go to run all cells. But I still getting the same error. Let me see. First, I need to check if it has created the folder. So I don't see anything here. Because if it's not creating the folder, then it cannot save the data. Then, okay, exit page. Why you're not responding now? Okay, oh, was bigger than I thought. Okay, where is it? Where is all my, okay. Because we should have a folder that is called, if we don't have the folder, then it will present an error. Our name of our folder was exported images. Yeah, it didn't create it. Okay. Okay. Expand user paths. Yeah, expand user exported images. Why? Okay. Let me just try this one. Ah, okay. Remember we put it here, downloaded images. You put it back to downloads. It downloaded the data, which I got it here along with other files that I had. Let me eliminate those. And I will download it again. Did it run for you?
Yeah,
Okay.
I got that too.
You too?
Some expired.
Okay, let me, if I rerun again, I'll see that the file here.
That error that I'm getting is on the very first, so.
There we go. That's the image. Okay, let me see your errors. Remember, go to GEEMAP example 118 and try to run. Yeah, the one that we ran last time. Just run.
Oh, I was just watching this part.
Okay. All right. So it's 118. Is one of the last, the one that we. What's that one? Okay, try running it. Oh, there you are. Close that bottom part. Yes, try doing the link again. Okay. GMAP, how this repository. Okay. These examples, notebooks, 118. Okay. Run cell by cell. I will show you there. Click on there. Okay. You got results?
I got the same thing until it expired.
Okay, go to GEEMAP. Samples. Your new is you got GEEMAP.
No,
The other repository.
no, I don't.
You didn't run it. Okay. First, you are running it.
Through the token
The
thing.
token, okay.
Yeah, I have an authorization code.
Okay, now that I've done that, I can go back and get it.
Yeah, go back to our notebook and run the. Okay. You can run all cells now. They run all cells.
So what does the token do?
The token is connecting the Google Earth engine with with this Python environment. For some reason, which is weird, the environment remembers your token forever. So you don't need to do this token again. So for some reason, yours didn't get there. But I also, yesterday when I was testing my code for today, I got a request for the token. So it's like, oh, weird. But now that you see that you also got the token required, I said, oh, something might have happened on the HydroShare part. But now that Landsat image is there. Now I can click, download, save. Let's see where it's saved. Okay, using my downloads. And if I have a software like ArcGIS Pro, I can visualize that image. So ArcGIS Pro, I would say, is way better to do zonal statistics. Let's say you have this image and you want to get average per county, or you have several polygons you need to extract data from the image. Yeah, ArcGIS Pro will be way easier. Or ArcMap or QGIS. Insert map, add data. Where is my? I need to move this file. Copy desktop. Too much stuff my desktop. Okay. Now I can go to computer. Where is my desktop? Oh, you man, make me look so. It's not there. You pasted. Yeah, there we go. It's reading the image. There we go. But I don't want the individual bands, so I want the entire image. So I need to go one level up. Here, open. That's the image I clipped around Lake Gourmet. So now I can do here also, I can do, because I brought all the bands, I can go to symbology and I can say, remember that false color combination, band 5, 3 and 2. False color. So ArcGIS Pro can also do similar things as Google Earth Engine. So the two softwares are compatible. So I got so what are the key here for download the image? The coordinates. So you have a good set of coordinates and you will reduce or expand the coordinates depending on the limitation on the download. But this is, let's see, this is about 28 kilometers wide. $15 kilometers. So it's not a small area.
Then project you want us to do this, like if match with what we're thinking, and then allow it.
You can, we haven't done yet much analysis, and those are the topics of the next sessions, lab session. So we do as much as we can in Google Earth Engine, and then the final result we can bring it to our ArcGIS Pro, our map, to do, let's say, zonal statistics if we need.
Installing ArcGIS Pro, we need license.
Yes. Who has ArcGIS Pro? Okay, you don't. Okay, what I need from you is your A number. Send me an email and I'll pass to the license manager, so you will receive an email and you will get the license for it. Okay. So, okay, who was able to download too? You? Okay.
No, it's okay, things still messing up.
Okay, did you open the? I think we can pause it here. Let's keep recording. Okay. You fix. Oh,
Oh, I have to change the size.
Oh yeah, the size. Play with you. So you were able to download it. Yeah. Congratulations. And you are almost there. No. Generate token. Check both. Go down, copy that code. Paste it. Okay. Now you can
hit twice. And
now go to our, okay, and you can run that one. Okay. Go to kernel. Restart kernel. Okay. Now go to run all cells. So everything that is with the star is being run. What it says here. Let's go to the end. Oh. Let's go up. It says image clip, scale, ROI, go up. There. But you have the image already. Now, yeah, those are the. Try reducing your coordinates. But now you should have. You got your image?
no, unfortunately, I don't know what that. All the
Can we see the coordinate that you try?
Say that again.
The coordinate that you try.
You want to see?
Yeah.
Ah. Okay, give me a second.
Still has the same.
Okay, coordinates I try.
Might coordinates be too small? Is that an issue? Because I did a pretty small area.
It shouldn't be an issue. Okay. Yeah. Yeah, okay. Okay. Open a terminal. LS. You are in the CD space plus dot. Okay. Okay. Now open a. This is going to put it outside. It is the major of the root folder. Okay. So go to GitHub, find GEEMAP. GitHub at the website. Yeah, at the top, the GEEMAP of the search box. Okay, the top one. Open. Copy the address. Go to terminal git space clone space copy enter.
So, you know, what the reason is that.
Deleted?
Yeah.
Not sure. But now you have refresh your folder. There is a circle. Click ls. That for first somewhere that it says that. Okay, click on the root folder. Oh, this is the folder. Yeah, it seems that usually in the root side the root for the account. Okay, so open that one. Oops. 118. From the first cells. There. Go to the link first. Generate token. Select all. Copy the code. Paste it there and okay. Go to our example. Okay. Go to kernel. Let's restart kernel. Start. This is what discuss back. Run all cells. So I may have to generate. No, the idea is that you just generate one time token. That's it.
Okay, so I thought I did it. I thought I said that it's live.
No, that was for the GitHub. This is the Google Engine. So going down. But it's yeah, you might want to reduce your area or use the coordinates I'm using screen cap to give it a try. So okay, do you still have issues with the video? Okay. Yeah, it's fluid and then you wanna put it, what? Oh, yeah, it's, yeah, it's on the, I gave, I'm putting the links to the YouTube video of the two sessions already. So you can watch it again. So, did yours run? Okay,
I have a couple errors, but,
you need help?
not
Yes,
really.
no.
I think it's just.
Okay, let's go down. The last one, so, if parallel district factor. So. So are you doing like coordinate too? Let's run from the top. Let's run. So. Okay, here. For the page. So again, your token seems to be expired open 108, 108. Run the first cells. Okay, go to the link. Get the token. Select both. Okay. Go to the notebook. The square. Control V. Go to your app. To your notebook. Okay. There. Just run it again. Yes. Okay, go back. Why? Okay. Okay, so it might be that the update didn't get to this kernel. So go to kernel, restart kernel. Restart. Okay, go to run off. Okay. Let's see the error. Okay.
I was like,
So what? It's called hold on. Okay, this address, did you copy from the from Landsat map? But this is different. So And you check. Okay.
Let's go back and look through the video and see if it's
Yeah.
a small. You'll let me know.
So what do we need to turn it in for a lab? Is there an assignment for this?
Yeah, I was going to think about the assignment until I got derailed by trouble.
Oh, I'm not quite.
Okay. Okay, well, I cannot give you an assignment if you are not able to finish the lab successfully. So that's my thing. So if you're having like errors, then you're going to stand with error for the entire week. So okay. Could you bring your laptop and see what's the difference between my code and your code? Or could you check this is this cell?
Which not, she got them.
She got error here. Very early in the
I got the same, but the reason I got, I don't know.
okay, let me see. You were having issues with the size?
No, I was.
You were able to download?
Yeah.
Okay, good.
I changed the size and it's still same error.
The same.
Error files.
Okay, let me see the error.
What did you-
Yeah, yours
What
is,
did you name your downloads folder?
your folder is downloads too, right?
It was a lowercase d. Because of my folder.
There you go.
Okay.
All right, check your folder. Do you have ArcGIS Pro?
Yeah.
Try to open the.
Okay, I don't have it on this computer though.
Yeah, but check that the image is downloaded. It is on the root folder. Open downloads. It does. There you go. Right click. Download. That's.
Okay. Okay, yeah.
Okay, you two
Thank
are
you.
okay. You.
I'm still a little too bad.
Oh. Okay. You can reduce the latitude. So latitude goes from 0 to 90, right? So you. But these are wrong. Oh, but my latitudes are different. Okay. So change this one to 45, and you have 35. Look at your record cell. Yes, now. Okay, you got it, and you need to change the previous assignment.
This is the V, right? So this.
Yes. Okay, so go to your the right click. Download. Okay, there you have. Now you have the data. Okay, you 3 years old.
Yeah.
Okay. I don't know the status of this guy. You will watch.
Yeah.
Okay. Okay. Well, we'll talk about the assignment of Tuesday. Then. Okay. Until we're sure that everybody is able to run. But all the labs are connected. Okay, so let's try to complete the activity of the lab and you run so you can do your assignment. Okay. Okay.
We got the first grade done now.
All
There's one
right.
more.
Okay. Okay, so I'm going to end the recording. Okay, if you're done, you can leave.